Car designers have always chased one impossible dream: building a vehicle that cuts through air like it does not exist. Most failed. But a few mad engineers actually succeeded, creating machines so smooth and strange that they looked like they belonged on runways instead of roads. These 4 cars pushed aerodynamics to absolutely ridiculous extremes, and none of them made it to your local dealership. Here is why. In the years after World War II, Italy was rebuilding. Bombed factories were rising again, and engineers were looking forward instead of backward. At Fiat headquarters in Turin, a small group of designers started dreaming about something wild. They wanted to put a jet engine in a car. The idea was not completely crazy. Aircraft turbines were becoming more reliable, and they offered smooth power at incredibly high speeds. So in 1948, Fiat secretly began developing a gas turbine engine small enough to fit in an automobile. By 1953, they had a working prototype. This was not a piston engine that thumps and rattles. This was a turbine that spun at 22,000 revolutions per minute, screaming like a miniature jet. The turbine produced around 300 horsepower, which was an enormous amount of power for a car in 1954. But raw power meant nothing if the car could not handle the speed. Fiat engineers knew aerodynamics would make or break this project. They spent months testing clay models in wind tunnels, shaving off every bump and curve that slowed the airflow. The result was the Fiat Turbina, a machine that looked like it had been carved from a single piece of soap. The body was extremely low and sleek, painted brilliant white with bold red racing stripes running down the center. At the rear, twin stabilizer fins jutted upward, giving the car a distinctly space-age appearance. The numbers told the real story. Wind tunnel tests revealed a drag coefficient of just 0.14. To put that in perspective, most modern sports cars struggle to get below 0.30. The Turbina was slicing through air with almost no resistance at all. This was a record that would stand unbeaten for decades. The engine sat right behind the passenger seats, mounted in the middle of the car. It drove the rear wheels directly without any gearbox or clutch. There was no transmission to shift, no gear lever to move. The driver had 2 pedals, one to go and one to stop. Press the throttle, and the turbine would spool up with a rising whoosh. Let off, and it would wind down like a plane landing. During test runs, engineers clocked the Turbina at around 250 kilometers per hour, which is about 160 miles per hour. For a car built in 1954, that was blistering fast. In April of that year, Fiat rolled the Turbina out for its first public demonstration. They chose the rooftop test track at the legendary Lingotto factory in Turin, a building famous for having a banked racetrack on its roof. Company president Gianni Agnelli showed up to watch, along with chief engineer Dante Giacosa and a crowd of curious journalists. The car was then driven to Turin-Caselle Airport for a larger demonstration. When the Turbina accelerated down the runway, it made a sound nobody had ever heard from an automobile. It was not the growl of a V8 or the whine of a racing engine. It was a pure, jet-like swoosh that echoed across the tarmac. People were stunned. The twin fins, the smooth white body, the incredible noise. It looked and sounded like the future. Newspapers ran photos of the Turbina on their front pages. For a moment, it seemed like turbine cars might actually become reality. But reality had other plans. As impressive as the Turbina was on a test track, it had serious problems for everyday use. The turbine engine guzzled fuel at an alarming rate. Worse, it generated enormous amounts of heat. Under normal city driving conditions, the engine would get dangerously hot, and there was no practical way to cool it down without adding heavy radiators that would ruin the lightweight design. Fuel economy was terrible, and the costs of running a turbine were far higher than a conventional engine. By the end of 1954, Fiat quietly shelved the project. The Turbina had proven that turbine power was possible, but not practical. It was simply too expensive, too thirsty, and too finicky for the real world. The dream of jet-powered family cars evaporated. Today, the one and only Fiat Turbina rests in the Museo Nazionale dell'Automobile in Turin. It sits behind glass, a relic of an optimistic era when engineers believed anything was possible. Visitors can walk around it and admire the flawless white body, the red stripes, and those iconic twin fins. But they will never hear that jet engine scream again. The Turbina remains frozen in time, a beautiful reminder that sometimes the most advanced machines are the ones that never make it past the prototype stage. By the late 1970s, the world had changed. The oil crisis had hit hard, and fuel prices had skyrocketed. Suddenly, big, thirsty engines did not seem so glamorous anymore. Governments across Europe began funding research programs to develop more efficient cars. In Germany, this effort was called Auto 2000, a government-backed initiative aimed at designing the car of the future. Mercedes-Benz took this challenge seriously. They had a reputation for building solid, luxurious automobiles, but luxury meant nothing if people could not afford to fill the tank. So, in 1981, Mercedes unveiled a concept car at the Frankfurt Motor Show that aimed to solve the fuel problem without sacrificing comfort or safety. They called it the Auto 2000, and it was a rolling laboratory packed with experimental ideas. The goal was ambitious. Mercedes engineers wanted to build a car that could carry 4 people and luggage, weigh up to 2,150 kilograms, and still achieve fuel consumption of just 11 liters per 100 kilometers. That works out to roughly 21 miles per gallon, which does not sound impressive by today's standards. But in 1981, for a car that heavy and that large, it was a monumental challenge. The first step was aerodynamics. The Auto 2000 had a long, low body with a sloping rear end designed in the comeback style. This design, named after German engineer Wunibald Kamm, cuts off the rear of the car abruptly to reduce drag without making the vehicle excessively long. The result was a drag coefficient of just 0.28, which was excellent for a full-size sedan at the time. But aerodynamics alone would not hit the fuel target. Mercedes needed to rethink the engine entirely, so they did something unusual. They built 3 completely different engines and tested all of them in the same car. The first engine was a 3.8-liter V8 gasoline engine with a trick up its sleeve. It could deactivate half of its cylinders when full power was not needed. During hard acceleration or climbing hills, all 8 cylinders fired, but during gentle cruising on the highway, the engine management system would shut off 4 cylinders, effectively turning the V8 into a 4-cylinder. This cylinder deactivation technology saved fuel without forcing the driver to give up performance. When you needed power, it was there. When you did not, the engine sipped fuel like a much smaller motor. The second engine was a 3.3-liter turbocharged diesel with twin turbochargers. Diesel engines are naturally more efficient than gasoline engines, and adding turbochargers boosted power without increasing fuel consumption. In testing, this diesel engine achieved fuel consumption of about 7.5 liters per 100 kilometers, while cruising at 120 kilometers per hour. That was significantly better than the target, proving that diesel technology had serious potential for the future. The third and most experimental option was a gas turbine engine, similar in concept to the one Fiat had tried nearly 30 years earlier. Mercedes engineers were curious whether turbine technology had improved enough to be practical. The turbine engine was compact, required no water cooling system, and ran extremely smoothly with very little vibration. It was also very light compared to a conventional engine. But just like the Fiat Turbina, the Mercedes turbine faced the same issues: high fuel consumption, and heat management problems. It was an interesting experiment, but not a solution. All three engines could be bolted to the same 4-speed automatic transmission, making the Auto 2000 a true test bed. Engineers could swap engines and compare results directly, learning what worked and what did not. Inside the car, Mercedes also experimented with safety and comfort features that were ahead of their time. The front seats had seat belts built directly into the seat backs, so the belts moved with the seat instead of being anchored to the car body. This made them more comfortable and easier to use. The rear seats had integrated child restraints, allowing parents to secure young children without needing separate car seats. The bumpers were designed to be softer and more forgiving in low-speed collisions, particularly to reduce injuries to pedestrians. While Mercedes was building a large, comfortable test car in Germany, Citroen was taking a completely different approach in France. The French automaker had always been known for quirky, unconventional designs. Their cars featured strange but brilliant engineering, like self-leveling hydropneumatic suspension and single-spoke steering wheels. So when the French government offered funding for fuel-efficient car research, Citroën did what they always did. They went weird. The project was called Eco 2000, and it ran from 1981 to 1984. The goal was to design a car for the year 2000 that used as little fuel as humanly possible. Citroën engineers were given a blank sheet of paper and told to ignore normal car design rules. The government funded half the research costs, which gave the team freedom to experiment. Over the course of 3 years, Citroën built several different prototypes. These cars were given internal code names like SA103, SA109, SA117, and SL10. Each version tested different ideas about weight, aerodynamics, and powertrain layout. The final and most refined version was the SL10, and it represented the peak of what Citroën learned during the project. The SL10 was tiny. It looked like a teardrop on wheels, with a smooth rounded nose and a long tapering tail. The entire body was designed in wind tunnels to minimize drag. The result was a drag coefficient of just 0.22, which was exceptional. Most cars in the early 1980s had drag coefficients around 0.35 or higher, so the SL10 was cutting through air with far less resistance. But the real magic was weight. The SL10 weighed only 450 kilograms, which is roughly 1,000 pounds. To put that in perspective, a modern Honda Civic weighs about 3 times as much. Citroën engineers stripped out everything that wasn't absolutely necessary. The body panels were thin, the frame was minimal, the interior was Spartan. Every gram mattered. Under the hood, or rather under the front body panel, sat a tiny 750 cubic centimeter 3-cylinder engine. This engine was adapted from a small Fiat motor and produced just 35 horsepower. Earlier prototypes like the SA103 had experimented with rear-mounted 2-cylinder engines. But Citroën eventually settled on a front-engine, front-wheel drive layout for better balance and control. Despite the small engine, Citroën gave the SL10 one of their trademark features: high-drop pneumatic suspension. This self-leveling suspension system used pressurized gas and fluid instead of traditional springs. It allowed the car to adjust its ride height and absorb bumps smoothly, even though the car was so light. It was a typically Citroën touch, adding complexity to achieve a specific kind of ride quality. The performance numbers were modest, but respectable. The SL10 could reach a top speed of around 140 kilometers per hour, which is about 87 miles per hour. That was enough for highway driving, though not much more. Acceleration was leisurely, as you would expect from a 35-horsepower engine. But fuel economy was where the SL10 truly shined. On average, the car consumed about 3.5 liters per 100 kilometers. That did not quite hit the ultimate goal of 2 liters per 100 kilometers, but it was still remarkable. More impressively, At a steady cruising speed of 90 kilometers per hour, the SL-10 could sip fuel at a rate of just 2.1 liters per 100 kilometers. That translates to over 100 miles per gallon. For a car that could carry passengers and luggage, that was an extraordinary achievement. Citroen never intended to sell the EQO 2000 prototypes. They were purely research vehicles, built to explore what was possible if fuel economy was the only priority. But the lessons learned from this project were not wasted. Many of the ideas about lightweight construction and small efficient engines influenced later Citroen models. The Citroen AX, a small economy car launched in 1986, borrowed heavily from the EQO 2000 research. It became one of the most fuel-efficient production cars of its era. The EQO 2000 project proved that extreme fuel economy was achievable, but it also revealed the trade-offs. A 450-kilogram car with a 35-horsepower engine was not practical for most people. It was too small, too slow, and too fragile for everyday use. But as a research exercise, it was invaluable. Citroën learned where the limits were, and that knowledge helped them build better real-world cars. By the early 1990s, American automakers were facing pressure from all sides. Japanese imports were dominating the market with reliable, fuel-efficient cars. Environmental regulations were getting stricter, and oil prices, though lower than the 1970s crisis, were still a concern. General Motors decided they needed to make a statement. They needed to show the world that American engineering could still innovate. So in 1992, GM unveiled the Ultralite, a concept car with one audacious goal: 100 miles per gallon. That number was not a typo. GM claimed the Ultralite could achieve 100 miles per gallon at a steady 50 miles per hour. The United States Environmental Protection Agency tested the car and gave it an overall rating of 88 miles per gallon, which was still phenomenal. For context, most cars in 1992 struggled to break 30 miles per gallon. The Ultralite was 3 times more efficient. To achieve this, GM needed to rethink everything. They could not just take an existing car and make it lighter. They needed to start from scratch. So they partnered with Burt Rutan, a legendary aircraft designer known for building experimental planes from composite materials. Rutan's company, Scaled Composites, specialized in carbon fiber construction, and GM wanted that expertise. The entire body and chassis of the Ultralite were made from carbon fiber composite. This material is incredibly strong, but extremely light. The complete carbon fiber shell weighed just 191 kilograms, which is about 420 pounds. The total weight of the entire car, including engine, transmission, wheels, and interior, was only 635 kilograms, or 1,400 pounds. That made it lighter than most motorcycles with sidecars. The shape of the Ultralite was smooth and rounded, like a river stone worn down by water. Every surface was optimized to reduce drag. The result was a drag coefficient of just 0.19, which was exceptional even by concept car standards. Most production cars in the 1990s had drag coefficients between 0.30 and 0.35, so the Ultralite was slipping through air with half the resistance. The doors were massive gullwing units that swung upward instead of outward. Because the carbon fiber body was so strong, GM did not need a center pillar between the front and rear seats. The entire side of the car opened up in one piece, making it incredibly easy to get in and out. It also gave the Ultralite a dramatic, futuristic look that turned heads everywhere it went. The engine was mounted at the rear of the car in what GM called a power pod. This was a 1.5-liter, 3-cylinder, 2-stroke engine rated at 111 horsepower. 2-stroke engines are simpler and lighter than traditional 4-stroke engines, though they tend to be less fuel efficient and produce more emissions. GM chose this engine because the weight savings were worth the trade-off. The engine connected to a 4-speed automatic transmission, borrowed from the Saturn brand, and the whole assembly could be removed and serviced as a single unit. Despite the small engine, the Ultralite was not slow. It could accelerate from 0 to 60 miles per hour in less than 8 seconds, which was respectable for a concept car. Top speed was around 135 miles per hour, though reaching that speed would obviously ruin the fuel economy. The point was that the Ultralite could be efficient without being boring. GM also gave the car an adjustable suspension system. At high speeds, the suspension would lower the car closer to the ground, reducing the gap between the body and the road. This cut aerodynamic drag even further. At low speeds, the suspension would raise the car up to clear speed bumps and driveways. It was a simple but effective way to optimize performance for different driving conditions. Inside, the Ultralite featured technology that was ahead of its time. The headlights used fiber optic cables to distribute light, and the taillights used LEDs instead of traditional bulbs. Both technologies were expensive and rare in 1992, but they saved weight and energy. The Ultralite made such an impression that Hollywood took notice. When filmmakers needed futuristic police cars for the 1993 movie Demolition Man, they based the design directly on the Ultralite. Copies of the car appeared throughout the film, cementing its status as a vision of the future.